Binary Thoughts. Hello everyone, and welcome to C++ lessons powered by binary-thoughts.net. You can find this lesson and more on binary-thoughts.net. In this lesson, I will be covering data types. I guess to get started, what is a data type? Well, data types can be looked at as variables or containers. These containers hold information just as variables in math hold numbers. The type of information that a container can hold depends on the type of the container. So basically, a data type holds data of a specific type. Pretty simple, huh? Why is this important? Without data types, we wouldn't be able to tell the computer to store information for us to access later. It's a crucial key in programming, and that's why we are learning about data types today. In C++, before we can use a data type, we must first declare it and then initialize it. We do this as follows. When declaring, we start with the data type, followed by a space, and then the identifier. The identifier is really just a name to distinguish it from others. When initializing a data type, we must first have that data type declared. If that data type is declared, we can then give the identifier a value. This is what we call initializing. Let's jump into some examples of using data types. Let's say I wanted to add two numbers together and then display the result. This is a pretty easy scenario, and we can approach this a couple different ways. We don't actually need data types to do this, but for the purpose of this video I will use some. There are several data types that will allow us to handle numbers, but the most common ones are ints, floats, and doubles. An int allows us to use any integer value as long as it's in range, and a float will allow us to use any number as long as it has enough memory to support it. A double is just a float with more dedicated memory, so it has a bigger range. The differences between the data types aren't really important for this situation, but it's something to keep in mind, especially later. There's also other data types that handle numbers for more specific cases. You should look those up if you're more interested, or if you need a specific data type for a specific case. In this case, I think we're just going to stick with ints. So before I can use an int, I must declare it and then initialize it. And remember that when you are using a data type, to declare it, you just type the name of the data type, followed by a space, and then an identifier. So I'm just going to name this one, or identify this one, as number. And now I can initialize it by giving it a value. I'm going to give number the value 1. So now number, which is a type int, has the value 1. So now we've created one number, and it has the value 1. So let's go ahead and create another number, and let's just call this one number 2. And let's set number 2 to 3. So now we've created two ints, which one holds the value of 1 and the other holds the value of 3. And their corresponding names are number and number 2. So now we just have to add the two together to get our result. Now there's a couple ways we can do this. We can create another int and name it result, let's say, and make result equal number plus number 2. Or we could just simply see out our number plus our number 2. Or we could see out our result. There's really a lot of different ways we could do this. I'll just show both, that way we can see that it works both ways. And I'm just going to do some stuff to make it easier to read for when we do have our output of the console window. If you're not sure what I'm doing, don't worry about it. I'm just making it easier, as I said, and I'll be covering this sort of stuff in another video, so don't worry about it. And I'm almost finished up here. And there we go. Now I'm going to set a breakpoint and run the application to see if we got the correct results. And as we can see here, we got 4 both times, just as we expected. So it's as simple as that. Let's run through a couple more examples and then look at some different data types. Let's look at some more examples of using data types, and let's specifically look at condensing steps. Pretty much what we're going to look at is just a shorter way of doing the same thing. And let's say we needed to use several data types of the same type. We actually had to do this in scenario 1, where we created 3 integers to hold 3 separate values. So let's just go ahead and stick with that same idea and say we needed 3 more integers to hold 3 more values. And we can actually declare these in the same step by typing the data type and then giving an identifier for each one. But the trick to it is just separating each one by a comma. So let's just do name 1, name 2, and name 3. So now I've declared 3 integers, one with the name 1, name 2, and name 3. And all I had to do was separate them by using commas. Remember, on the last one you do still have to use your semicolon. And that's just basic syntax. So now I could use these just as I needed to. Let's say I wanted to give name 1 the value of 23, name 2 the value of 43, and name 3 the value of 53. So, and that is valid. Now we could have actually declared and initialized these all in the same step. That gets a little unnecessary in my opinion, but just note that it is out there. So what we're actually saying in this first line is we're declaring an integer with the identifier name 1, and we're also setting it to the value 1, all in the same step, and so on with the others, and that's valid. So at that point we could have actually just used name 1 plus name 2, and that will actually give us some sort of value. We can actually see that if we wanted to display that to console. And let's do that real quick. I already have my breakpoint, so we should be able to see that. And on the console, we still get our results from the first 2. And if we remember, our name 1 was set to 1, and our name 2 was set to 3, so 1 plus 3 is indeed 4, and that's shown on the console. It's probably bad numbers to pick since it's the same result as the previous one. So let's just go ahead and change those real quick, and let's just do 34. So we should get roughly 37, or not roughly, exactly 37. And we do get 37 indeed. So that's just a quick example how you can really condense your code. Condensing is always not the best thing to do. The best code is the most readable code in my opinion. But just note that it is out there, and if you see it, you should know what's going on now. We've looked at data types and we learned how to declare them and initialize them at a very basic level. There are some things I want to note about using data types, specifically looking at their identifiers. Identifiers can only be letters, digits, and single underscore characters. What is meant by this is when you're declaring a data type and you're giving it an identifier, the identifier can only contain letters, digits, and underscores. So it can't have any question marks or forward slashes or anything weird like that. Only the letters, digits, and underscores. Now, the amount of underscores you can use is really compiler specific. Some compilers do allow you to use multiple underscores, and some compilers only allow you to use single underscores. So it's better to get in the habit of only using single underscores. If you have to use multiple underscores, separate them out by using by spacing them out between letters and digits, or a combination of both. And it's just a good habit to get into. Another thing I want to note about identifiers is most identifiers can only be started with a letter. So when you're giving a data type an identifier, it can only be a letter to start with, and then you can use numbers and underscores. Again, some compilers do allow you to use underscores to start, but it's a bad habit to get into, especially if you're working with people on a project and you're not sure what platform or compiler they're using. So starting with a letter makes your code really versatile, and it can really go pretty much run on any platform. So you always want to start with a letter. And last thing I want to mention about identifiers is identifier names can't be used if they're already taken. Kind of seems like common sense. We can't declare something twice. For instance, up here we have declared an integer with the identifier number. So down here, if we were to declare a integer with the name number or the identifier number, this wouldn't work. When we go to compile our code, our compiler won't allow it. And I can show this real quick by compiling the code, and it comes up with errors, and if I look at the errors, it points right to it that this is already declared, and it was previously declared up here. So you can't do that. The reason why why I'm pointing this out is because some things are declared behind the scenes, and you can't use stuff even if you weren't the one that declared it. For instance, your compiler might have specific things that are declared in the background, so if you try to declare something with that same identifier, it won't allow you to. And most compilers and systems declare stuff by using underscores first, which is another reason why you shouldn't use underscores to start your identifiers. Another thing is you can't use things that have already been declared, period. For instance, the type int is already declared somewhere, so you can't give an identifier with the name int. And there are several different ones in C++ that you just can't use because it's already declared either in the standard library or just C++ itself. So those are things to know, and if you do run into any declaring things, you might want to research what you're trying to use your identifier as to solve the error that you're getting. Now, I don't think I'm going to go through each individual data type in this video. I think I'm going to create separate videos for each data type that I am going to cover. That way I can go in depth on each data type and show what each data type can do individually, because not all data types can do the same thing. So if you're interested in ints or floats or strings or just different data types in general, look for my videos on those as well, and I will cover those more in depth individually. I think this pretty much covers up this video on data types, and if you want to find more information on this video, you can go to binary-thoughts.net, and I'll also upload this CPP file. That way you guys can open this project and just review some of the stuff we covered. Thanks for watching.